In this lesson, we're going to talk about deductive reasoning, the law of detachment, and the law of syllogism. Let's start off with deductive reasoning. So we talked about inductive reasoning. Now let's talk about deductive reasoning. So deductive reasoning is the process of reasoning logically from given statements to a conclusion. So, process of reasoning logically from given statements to a conclusion. So let's look at a scenario. Suppose a mechanic begins to work on a car and finds that the car will not start. Can the mechanic conclude that the car has a dead battery? Well, so let's think. If you were this mechanic and the car doesn't start, do you immediately jump to, oh, it's got to have a dead battery? Probably not. If you're a trained mechanic, then there are some things you need to check. There's a process for seeing why it won't start. Okay, there's more than just a dead battery that could be the case. It could be a bad starter, might not have gas. It could be the battery, but it could be some other things. So you want to reason logically from this process. So let's look at the law of detachment. Okay, the law of detachment says that if P implies Q is a true statement, and P is true, then Q is true. Okay, so in the last lesson we talked about our conditional statements where they're always valid, but they're not necessarily always true. So the law of detachment says if our conditional statement, P implies Q, is true, and we know that P, remember P is the hypothesis, if we know the hypothesis is true, then that forces the conclusion to be true, according to our conditional statement. So the major premise in law of detachment is the conditional statement. That's the original one that we're given. Minor premise are any secondary hypotheses that we draw conclusions from. Okay, so let's look at an example. Example 1, anyone late to practice will run laps. Alright, so that's our given statement. Let's start in part A by converting that to a conditional. Alright, so this is our conditional statement. If you are late to practice, then, well, you're going to run laps. Okay, so we've got our hypothesis here and our conclusion here. Okay, our P and our Q. Okay, let's look at the converse. Okay, if you run laps, remember the converse is Q implies P. Our conditional is P implies Q. Okay, if you run laps, then our hypothesis, you are late to practice. So we said that the conditional is always valid, is the converse. So does this make sense? If you ran laps, then you are, or maybe were, late to practice? Well, if you ran laps, you might have just been running laps because that's what everybody does at the beginning of practice. So that doesn't necessarily imply that you were late. So that's not valid. The converse is not a valid argument. Okay, so let's go to the inverse. Inverse is where we have our negation of P implies negation of Q. If you are not late to practice, then you will not run laps. That's what the inverse would say. Okay, and again, that's kind of similar to what the converse is saying. If you weren't late to practice, you could still run laps. Okay, if you badmouth the coach, or if just running laps is part of practice. So inverse is not valid either. The last one, how about the contrapositive? Okay, this is where we take our converse and inverse and combine them. So not Q implies not P. Switch them and negate them. If you didn't run laps, then you were not late to practice. Okay, so is that valid? So if you didn't run laps, then you are not late to practice. The conditional says, well, if you're late to practice, then you will run laps. So this is a valid statement as well. So the contrapositive is valid. Okay, so let's look at the law of syllogism. Okay, the law of syllogism says if P implies Q and Q implies R, so now we've got a third piece here. If they are true statements, then P implies R is also a true statement. Okay, so let's look at what we're saying. If P implies Q, that's what we're used to. Hypothesis implies conclusion. And if we have a second statement that takes the conclusion of the previous one, that implies another piece, a new conclusion. If they're both true statements, then the original hypothesis implies that second conclusion. Okay, notice we've got the same statement as the conclusion of the first, hypothesis of the second. Okay, let's look at an example. If a number ends in 0, then it is divisible by 10. Okay, so let's go ahead and do our P's and Q's. A number ends in 0, that's our P. Then it is divisible by 10, that's our Q. Okay, our second statement says if a number is divisible by 10, all right, that uses the Q from our first statement. Okay, then it says then it is divisible by 5. That's new. We haven't said that here or here, so let's give that a different letter to represent it. Let's call that R. So we've got P implies Q. We've got Q implies R. Okay, are they both true? If a number ends in 0, is it divisible by 10? Yep, that's true. If a number is divisible by 10, then it is divisible by 5. Yep, 5 is a factor of 10, so anything divisible by 10 is also divisible by 5. Good, so we got both true statements. So law of syllogism says that we can take, what I like to do is kind of circle these two Q's here, and then what you've got left, you've got your P and your R. What you've got left is your conclusion. P implies R. So let's take our P up here. If a number ends in 0, then, and then our R statement says it is divisible by 5. Alright, so that's our conclusion. P implies R using the law of syllogism. Okay, let's look at another example. If a number is prime, then it does not have repeated factors. If a number does not have repeated factors, then it is not a perfect square. Alright, so let's look at our P's and Q's. Here's our P. Here's our Q. If a number does not have repeated factors, there's our Q again. And we've got a new statement. It's not a perfect square. That's our R. Okay, go ahead in your notes and write the conclusion to these two major premises. Alright, I'm going to go ahead and look at example number 3. It says, if it is snowing, then you wear a jacket. If you wear a jacket, then it is cold outside. Actually, why don't you go ahead and do that one in your notes as well. Okay, so two good examples that I'll look at when I check your notes. Okay, let's look at one last thing, a combination of the two. Okay, the law of syllogism together with the law of detachment. Alright, this is the good stuff. Alright, so first example says Shannon lives in Louisville. So they just straight out give us a statement. That must be true. Second statement, if you live in Louisville, then you live in Kentucky. If you live in Kentucky, then you live in the United States. What can we conclude? Well, let's see here. We've got a given statement of fact. We've got two conditionals here. So let's do our P's and Q's. You live in Louisville is a P. You live in Kentucky is a Q. That shows up as the hypothesis of our next statement. So that's a Q again. And then we've got a new statement. You live in the US. That's our R. Okay, so we've got our two Q's here. So if we were to look at our P implies Q and our Q implies R, we've got diagonal Q's. So we can conclude P implies R, which says if you live in Louisville, did I spell it right? Nope. Let's squeeze an S in there. Then you live in the US. Okay, but that's not our final conclusion. Don't forget, we're told that Shannon lives in Louisville. So, using the law of detachment, Shannon lives in Louisville. Anyone who lives in Louisville also lives in the US. So therefore, Shannon must live or lives in the US. Okay, so that's our final conclusion using both law of syllogism and the law of detachment. Okay, one more example. Maybe let's cut this one off a little bit from that previous one. Got a little close. Alright, so this one says, the Volga River is in Europe. Alright, statement of fact. First conditional says, if a river is less than 2,300 miles long, it is not one of the world's 10 longest rivers. go ahead and do my P's and Q's. P, Q. Okay, if a river is in Europe, okay, now be careful here. We haven't seen that one yet. So let's give it a new name. Then it is less than 2,300 miles long. Now we've seen that. That's our P statement. So let's make sure that we label that as P. Okay. So here's what we've got. We've got P implies Q as our first statement. And we've got R implies P. Okay, so we've got two statements. Now notice that we've got this diagonal of the same statements again. If we see that, then we can use the law of syllogism here. Okay, let's take what's left. We've got our R as our hypothesis and our Q as our conclusion. And even though they're not in the same order as our previous examples, law of syllogism still stands. We could totally switch these two conditional statements here if we wanted to. The order of the individual statements is not important. Okay, so R implies Q. So that's saying if a river is in Europe, then it is not one of the world's 10 longest rivers. It is not. One of the world's 10 longest rivers. Okay, but now we're not done yet. We're given this statement here that we haven't used yet. So this says the Volga River is in Europe. Do we know anything about rivers being in Europe? Yeah, if we look at our conclusion statement, our minor premise that we got from our law of syllogism, it says if a river is in Europe, then it is not one of the world's 10 longest rivers. So we can conclude that the Volga River, since it's in Europe, is not one of the world's 10 longest rivers. So sadly, it didn't make the cut. Volga River is not one of the world's 10 longest rivers. And that is deductive reasoning, law of syllogism, and law of detachment.